In order to teach model new capability, you need new data. The new data can be produced depending on the problem that you're solving in many ways. In some scenarios, you can produce the new data purely synthetically. But then if you want to teach a model completely new thing that there is no other model that has knowledge of that, you have to produce that data with humans.
Welcome to the AI and Scale podcast. This is a show that invites AI practitioners and AI experts to share their experiences, challenges, and AI success stories. These conversations will provide answers to your questions. How do I implement AI successfully and sustainably? How do I make a real impact with AI? Our podcast features real AI solutions and innovations, all of them ready for you to harness, and offer a sneak peek into the future. Welcome. This is Gosia Gorska, the host of the Schneider Electric AI at Scale podcast. Today, I have a big pleasure to welcome Manu Sharma. Manu is the founder and CEO of Labelbox, the leading data factory for building next-gen AI. Welcome, Manu.
Thank you for having me.
Yeah, it's a pleasure, really. Manu, I've been reading about you and I was so excited to discover that you developed products at Planet Labs and Drone Deploy, and you co-founded renewable energy and space exploration companies. It started with you studying aerospace engineering and a wide range of robotics, electrical engineering, and industrial design subjects. You hold master's degree from Stanford University and Embry-Riddle Aeronautical University. Tell me, how are you still doing something in this field?
First of all, thank you again for having me. And you did quite some research. I am a pilot. I fly planes, and I think that's my closest to being in sort of an aviation aeronautics world. However, I am very deeply optimist and passionate about space exploration. And I think, in my lifetime, we're going to go to Mars and we're going to explore a lot of parts of our solar system. And so that is part of me that is always curious and excited about the development in this sector. But yeah, my day-to-day work is in artificial intelligence, and the artificial intelligence is a very exciting industry at the moment. And when I was growing up and I was in university, I was very, very fascinated by AI at that time. Mm-hmm. And in fact, when I was pursuing my aeronautical engineering, I spent most of my time doing research in AI. I developed algorithms with neural networks to control flight characteristics. Mm-hmm. Essentially, flight controls typically are built with classical systems. And I was very curious about, could we train neural networks to control the flight? And so that's like maybe 15 years ago at this point. And so my interest in AI was always there. And fast forward in 2018, when everything was sort of coming together, the hardware technologies were getting really, really good. The algorithms of deep learning were becoming mainstream. That's when I thought that this was the time to build a company like Labelbox.
Okay, I see. But I'm curious, you need to give me the answer. So can large language models actually control flights or not?
They are going to be able to do so. And, the applications of large language models are particularly well suited in scenarios where you don't know what to do. What would be an example of that? So like a lot of the humanoid robots or the industry of robotics is now kind of growing really fast because a lot of people are finally realizing that they have the missing piece. They have an intelligent system that can perceive the surrounding and can navigate the surrounding to accomplish a task. And I think that this paradigm, this kind of system integration of robotics, the large language models, the vision models, you call them just like large models, essentially. Mm-hmm. I think that's a winning recipe to make these systems work in the physical world. And I think this is a great architecture for space exploration as well. So let's say we want to send hundreds of robots to Mars to, explore the surroundings and the world. It will be, I think, a lot effective if you have large language models operating at the edge to make the decisions. Right now, decisions are made every 8 minutes or so because of the lag between the time it takes for the signals to travel between the two places. So if you have a very intelligent system, it can make those decisions right there and only prioritize the important data to set back. And in fact, this kind of technology of prioritization of the right data to send is something companies like Planet Labs started developing maybe like 7-8 years ago. We were capturing the entire Earth with 300 or so satellites every day. And sometimes we wanted the fleet to prioritize and tell us which image is really, really like the one we should look at. And it was very, very early days of those ideas. And I'm sure now many, many companies like that operates with that kind of architecture.
Yeah, that's really fascinating. And you mentioned image, and I think this is the area where we will direct our conversation right now, because I guess this is related to data labeling. And one of the kinds of the data labeling is exactly labeling the images that are needed for AI system to cooperate with a human and bring some of this intelligence to us as well. But the first question before we go into the details of this, how did you decide you wanted to launch a startup? And was the Labelbox the first one? Was there any particular reason why you have chosen exactly the data labeling field?
Yeah, so this is perhaps the third company. I had two small businesses that I operated, both actually during my university time. So when I was pursuing bachelor's, I was really interested in wind turbines, residential wind turbines. So we attempted to kind of transition from a research project to a small business company. And then later on, I actually developed a small business around building small CubeSats or small satellites, call them like small experiment modules that will go to International Space Station and allow researchers to do experiments remotely. So they could like log onto a website and control those experiments in International Space Station. And these were small businesses, they were in a very niche industry. And, the most important elements of those experiences is that it was just a lot of fun to have ideas, to solve problems, and just go out there and interact with the world and the market and make those things happen. So it was super cool. Like I was in university taking classes, but in the evenings I was, building these research labs that will go to space station, on SpaceX rocket and Antares rocket at the time. And so that was a very fun adventure of my life. And during these experiences and later on in my experience, I learned how professional software development happened. And so joining Drone Deploy or Planet Labs, those experiences really taught me how to produce software at very large scale. And that is something that I did not knew since I was mostly in non-software industries. I was mostly doing software on the side. And that experience led me to really understand like how to build technology companies, software companies, principles of like how to take an idea, decompose that into smaller tasks, and then work with engineering to develop those things together and do that in a very fast, iterative manner. And so those were the things that I learned for the first time in a professional setting. And in 2018, 2017, deep learning was the hot topic in Silicon Valley. Self-driving cars startups were popping up here and there. And at Planet, we were also starting to build computer vision technologies. And because, of course, like our business at the time was simply selling images, and our customers wanted more than images. They wanted to understand insights in their geography, in their area of interest. And so we started developing these vision models, and we quickly realized, and I was seeing it kind of from a perspective of like, hey, what are all the tools and techniques needed to develop these vision models? And a big part of that was data. You essentially needed, obviously, talent, but compute and data were second big categories of ingredients needed to develop AI systems. Turns out the same is true even today. And the data part was particularly interesting because if you were to extrapolate, and we extrapolated the trends like 10 years from that, like from that moment, we often would come down to having the same realization that humans will always want AI systems to be aligned to them. And, I cannot imagine any company wanting the AI to just do whatever it wants. Everyone wants AI to do something for them. In a sense, humans want AI to be used as a tool.
Mm-hmm.
And to ensure AI is always doing what humans want, you have to align these models and constantly align these models. And the primary form of that alignment is through data, because that is the interface. Like, that is just how we communicate with these models. Mm-hmm. And that was sort of the bet we made on, that we built the company around, which is the world is going to have lots of AI models. A lot of people would want these models to do something unique for them. And that means they would need to align these models. And the primary way to aligning these models would be in a form of data. And we can build a company that helps businesses to align models through data labeling. And that's sort of the progression, like, of how we went about building the company. And yet today, fast forward, vision models obviously are aligned with this, like, data labeling techniques. Back in the day, it used to be very manual.
Mm-hmm.
Now it's heavily AI accelerated. So the human supervision element is much more smaller and on demand in places where the model really is struggling. And same is true with the large language models. And in fact, all of these vision and language are converging together. A single model basically can reason in computer vision and vision space as well as language space. And that's really, really exciting. Uh-huh. And so these models continue to be aligned and trained or fine-tuned with data. You need labeled data for it. There are different techniques of aligning these models. Back in the days, used to be kind of like supervised training. It continues to be still play a very important role in many domains for task-specific models. But for the larger models, for vision or large language models, the techniques like RLHF, reinforcement learning from human feedback, has been kind of the cornerstone of the success. And the key insight there is that instead of asking humans to do all of the meticulous work of labeling, let's just ask humans what they prefer. And asking humans to choose one option versus, the 2 or 3 options is a lot more easier task than to write like an essay or to write like a technical plan and so forth. The AI automatically generates those plans. The only job of human is to choose the one they want. And this way, the AI can start tuning and learning itself to respond in the manner that the human prefers. And that's kind of a very simplified way of understanding it. And that is the core innovation behind these transformer models and that all the assistants we see. Of course, there are lots of algorithmic and hardware and all of the techniques. There are more techniques and more kind of things that are needed to make these models work. But this is one of the very important cornerstone or bedrock technology behind it. And this is all data labeling.
Yeah, that's all data labeling, exactly. So I think for people who are already reading and they are interested, they are maybe studying AI, this whole concept is quite clear. But if you were just about to give a simple definition of the role of data labeling, how it plays in AI, and you already described a bit how it changed over the years, but coming to today, how are businesses using data labeling and why it's needed? Because I think that the general awareness is more focused on how large language models or vision recognition models are working. But we still forget about this input side, as you said, and the fact that the data has to be of high quality and it has to be labeled with also high accuracy. So how do you ensure this in Labelbox? And if you could start with maybe a simple definition.
Yeah, so any business that is developing a unique differentiated AI model, and again, this is very important because not all the companies in the world are going to be doing that. Only a smaller fraction of the companies are going to develop AI systems that are from ground up because they have the most unique data that they have been producing by the virtue of their existence. And so what are those kind of companies? I mean, a very simple example would be companies like Google or Meta. They have social networks, they have search engines, they have all these software applications, and it's producing a ton of data that only they can produce at that scale. But then there's also companies like Schneider Electric. There's many companies in industrial sector. One of the companies comes to my mind is John Deere. They have tractors, they have cameras on the tractors in agricultural context. And, only that company can produce and capture that data at scale. So they have unique advantage. If they take that data and use that to build new forms of product capabilities, it will likely be coming from artificial intelligence. They can build AI to automate or make some decisions that in the industry are very valuable. So for John Deere, their decision to identify where are particular weeds in the farm so that they can kill the weed with herbicides is a very important decision to make. In fact, if their technology is used pervasively around the world, they can reduce the herbicide application by 90%, which will be really great for the world. And similarly, in use cases like Schneider Electric or similar industrial companies, there's so many cases around manufacturing, defect analysis, and so forth. A lot of these use cases are unique to the companies, and some companies decide they want to go build AI models to streamline, automate, enhance their operations or products and services. Now, in order to do that, you have to produce data to train these models. You have to produce the high quality labeled data to produce these models. And that's in a nutshell, what is data labeling. That's in a nutshell kind of like describes like why you need data labeling. It is to train customized, unique AI models in the world. Now, the data labeling is very different for different kinds of model capabilities. And you asked me, how do we produce data at scale with really high quality? This is actually one of the very complex problems. Not every company can do this at scale. It's a very, very difficult research and engineering problem. So we have a number of strategies and techniques that we have developed to produce data at scale. First of all, depending on the nature of the task, you have to have expert humans. So for large language models, for most generative AI applications, the data labeling have to be done by expert humans. So to give you an example, state-of-the-art large language models today require people with backgrounds in PhDs or linguists, like really advanced language skills in a variety of languages. They also require some of the best software engineers to label data so that these models, the frontier models, the ones that you may have heard of or you may be using every day, in order to teach them new capabilities. So the data labeling for these large language models has become an extremely sophisticated task. And so Labelbox has one of the largest networks of these expert humans, AI tutors, around the world. We have a lot of university professors or domain experts in industries, software engineers from all the big companies like Google, Amazon, or language experts across Europe or India or even US and South America or Japan, Korea. Lots of these people are part of our network. They join on aligner.com. Our network is called aligner.com with double R. And they are able to label data, participate on part-time jobs of labeling data, and get paid. And so having a network is a starting point. But then to produce the data at scale, at quality, a lot of things goes in software and AI. So our platform, our software layer that manages all the tasks and is able to kind of orchestrate data production as one would think about producing like parts in a factory, in an assembly line with modern school of thought. So breaking down the task into smaller tasks, making sure that there's quality QA, QC processes in every step of the way, automate anything that can be automated. And of course, measuring at every step the quality of data that is being produced. Again, there are multiple steps in producing these data sets, and measuring at every aspect or every step of the way is very important so that once you measure, then you can improve. So we do a lot of these things to produce data at scale.
Yeah, and it's really great, Manu, that you mentioned about this opportunity to participate as a part-time job in this kind of projects, because I think it's a beautiful alternative to what something is irritating us on some of the web pages where we are asked for free to select some pictures that are I don't know, a car or a tree or a bus, and we know that we are probably doing it. It's a part of data labeling. We do it for free as an exercise just to enter a specific web page, while you are offering an alternative where you can be actually a part-time cooperator in the project by labeling the data according to your expertise. I think it's a really great idea.
Yeah, absolutely. And, tens of thousands of people are actively making money doing these tasks on our network. And, people are making money on their side. That means that they have more options and they can do more things in their lives. And the wages are very, very compelling. Some of the best people, best aligners are making over $100 to $150 an hour doing these tasks. Like, this is a compelling job as a part-time that people do on their own time.
Yeah, that's a great idea. And talking about specific examples, you already started to share some of them with us, like in the agriculture or in the industry. Could you give us some examples where the data that was labeled has improved machine learning model performance in some concrete applications?
Yeah, there are many examples. Let's just start with the example that I was using with computer vision application, where, again, the primary task in computer vision typically is to identify objects with high precision and ideally also with high accuracy. Typically, the pursuit for improving these models comes from building a data engine, which is very similar to how Tesla Autopilot is designed. A lot of these terms like data engine was coined by the team of Tesla Autopilot that first popularized how to build these very advanced vision models at scale. And the idea is that if let's say in John Deere's example, they have cameras in tractors, they are identifying weeds. There are a lot of different variation. The lighting conditions can be, could be in morning, could be in evening. It could be raining some of the days. And so you can imagine the photos coming from the sensor are very different depending on where the tractors are. And the vision models typically may not perform really, really well across all of the scenarios. And so in order to improve the performance of the model, the machine learning team has to prioritize and figure out where the model is not performing. It might be, let's say, it's during the dawn or the dusk in the early hours or the late hours, where the lighting conditions are poor. That's when the cameras really struggle, the AI systems really struggle to detect weeds. Then the natural next step is to actually label that data with humans so that the AI model can see more examples of these edge cases or scenarios and potentially learn from them so that it learns to identify weeds in those scenarios. That's an example of like how more data in this particular context improves model performance. And so our customers over the last few years have went from an R&D, like a research project, to production deployed products that are generating revenue at a large scale. So we have seen these companies from an idea to a completely like revenue generating or a very important deployed models, primarily through the function of like these constant iterations. They start with the idea, they rolled out a product, then they captured more data, they prioritize which data to label, they retrain their model, and so forth. Now, in large language model application, there are very similar scenarios. So our company is behind many of these large language models or AI assistants that people use around the world. And the data that goes into these models is very, very interesting right now. Most of these frontier model developers, let's say ChatGPT, Gemini, Llama, and so forth, all of those ones, they're really focused on three things. They're focused on reasoning, teaching the models advanced reasoning skills so they can do more complex tasks. Well, the data behind that actually is very interesting. It is produced by experts with PhDs in software and STEM backgrounds And the data looks like taking a complex problem and solving it in step-by-step instructions. And this is sort of like, teaching the model baby steps, like, hey, here's a very complex problem. Here's how to think about it. And here are 10 smaller steps, like logical steps that you may take to solving that. And this data is not available on internet. Like, so if you train these models on internet data, internet is full of everything, but it does not have like this very well-crafted, high-quality reasoning data. And that's an example of how Labelbox has been behind the scene, providing data like this to these frontier labs that is teaching the new advanced skills of reasoning that the rest of the world uses. And so that's some of the few examples. I think the key thing behind all of this is that in order to teach model new capability, you need new data. And the new data can be produced depending on the problem that you're solving in many ways. In some scenarios, you can produce the new data purely synthetically because the problem that you're solving is inherently solved by some model. Some big model already knows everything about that problem. It's just that you want to train a much smaller model that only wants to be really good at doing that thing. And so you can do these techniques like model distillation or synthetic data creation from many models and train a smaller model. Okay, that's very proven technique. But then if you want to teach a model completely new thing that there is no other model that has knowledge of that, you have to produce that data with humans, with, of course, AI assistants. And so that's kind of the commonality across the board.
I see. And I'm glad that we are moving away from training models only on the internet data because, as you were mentioning, we need this high quality expertise coming from humans. And if we just remain at the level of internet, we would just be feeding, like in the saying, the garbage in, garbage out. The models are not able to move beyond certain level of reasoning, let's say. So you described the current status of technology. What's your take on the future? You say that Labelbox is the data factory for the next Gen AI. So what's next in Gen AI and how the future looks like?
Well, I think there are 3 dimensions. All of these frontier models are going to be improved. So first of all, these models right now are really good in English. However, their performance are not comparable in other languages. So if you are in India, speaking Hindi, if you're in, talking to these models in, different languages, maybe like, Polish perhaps, like these models are not so sophisticated yet, and they can often make more errors in those languages. So the focus you should totally expect these models to get very, very good in other languages very quickly. Then these models are going to be much more advanced in reasoning capabilities. They will be able to solve a lot of problems, very hard problems in math, science, and so forth. And that basically means that, that is a glimpse of hope for how these models will be able to do agentic tasks, which is, in other words, in enterprise context, assistants can only get you so far. Okay, so assistants are going to be good for knowledge help. But in enterprise, you really need to think about solving complex problems, complex tasks, which might require talking to 5 different software systems and manipulating the data and all that. So it's a very, very complex situation. And very soon, these large language models will have the ability to be able to talk to all the 5 software stacks or different systems and solve the problem, manipulate the data along the way, and do that in a reliable manner, right? So that is kind of what advanced reasoning gives us at a tactical level at enterprise. And then third thing is going to be multimodality. So basically, we are seeing the architectures converge where if you're solving a vision problem or a language problem, you're not going to be using different model architectures for that. You're going to be basically using the same model that can actually do all of those tasks together. And so you want to be able to talk to a model, with with images, like sending images. You want to be able to talk to the model with video and text and documents. And so they're all going to be, all of these things will be possible with a single model.
Oh, I see. That's an interesting vision of the future. We are looking forward to it. It was a pleasure to talk with you, Manu. Thank you so much for your time with us.
Thanks for joining us today on AI at Scale podcast. Be sure to visit our se.com/AI website and learn more about our AI at Scale solutions. Head over to our Schneider blog platform to read more. Don't forget to subscribe to the show on your preferred platform and share it with your network. Thank you for listening and stay tuned for the next episode.